The focus of a parabolic mirror is at a distance of 5 cm from its vertex. If the mirror is 45 cm deep, find the distance AB in the figure. So we have this parabolic mirror. The focus is at a distance of 5 cm from the vertex, and the mirror is 45 cm deep. We have to figure out this distance AB. So this is AB. Observe the figure, pause the video, and try this on your own. Okay, let's do this together. Now the question just talks about a parabolic mirror. It gives some dimensions of the parabola, but it doesn't tell us where the parabola is. So to make things convenient for us, let's assume that the vertex of the parabola is at the origin and it's a rightward facing parabola. If we do that, we can pinpoint the focus. It's at 5, 0 because it's at a distance of 5 units from the origin. So this is 5, 0. And we can also say that the equation of the parabola is y square equals to 4ax. Using 5, 0 as focus, we can figure out this value of a. Because the focus for y square equals to 4ax is a, 0. Comparing this gives us a equals to 5. Which means the equation of this parabola is actually y square equals to 4 times 5 times x. That's y square equals to 20x. So now we have the equation of the parabola. We need to figure out this length AB. It's not the lattice rectum. The lattice rectum would have passed through the focus. It's some other chord. Now how do we figure the length of this chord? Think about it. Well, the parabola is symmetric about the axis. This length is equal to this length. To get this complete length AB, we can figure out the half of it. And what's that? It's the y coordinate for this point. So to get the length of AB, we need the y coordinate for this point A. And do we have the x coordinate? Yes, we do. We know that the parabola is 45 centimeters deep, which means this length is 45, which means the x coordinate is 45. So at x equals to 45, what is the y coordinate? There is going to be two y coordinates, one for A, the other for B. We need just one of them. So how do we figure that out? We can plug in x equals to 45 in the equation. Let's do that. Y square equals to 20x, x here is 45. So 20 times 45, that's going to be 2 times 45, that's 90 times 10, that's 900. So y square is 900. We can take the square root. Y is plus minus 30, which means the point A is at 45, 30 and the point B is at 45, minus 30. But we care about the length. So we know that this length is 30. We can double it and get the value of AB. So AB is 2 times 30. That's going to be 60 centimeters. So for this parabolic mirror, AB is equal to 60 units or 60 centimeters. Let's take one more. A beam is supported at its ends by supports which are 12 meters apart. Another information here is in centimeters. So let's convert this 12 meters into centimeters. Let's draw the figure. So this is our beam and it's supported by these two ends. These are 12 meters apart, which means they are 1200 centimeters apart. All right. What else do we know? Since the load is concentrated at its center, so the beam is bent like this because there is load concentrated at the center. There is a deflection of 3 centimeters at the center, which means this length is 3 units. And the deflected beam is in the shape of a parabola. All right. This shape is given to be a parabola. The question is, how far from the center is the deflection 1 centimeter? At the ends, there's very little deflection. At the center, there's the maximum deflection of 3 units, 3 centimeter. The question is, how far from the center? How far from the center is the deflection 1 centimeter? So this is 1. We need to figure out this length. From the center, the distance between this point and this point. How do we figure this out? Pause the video, try this out. Okay, let's do this together. Again, for our convenience, let the vertex be at the origin. This is an upward parabola. Let's assume the equation to be x square equals to 4ay. Can we figure out the equation of this parabola? Okay, what do we know? Can we figure out a point here whose coordinates we know? This is 0, 0, the vertex. Any other point we can figure out? This is 0, 3. What about this point? What's the coordinate for this point? To reach this point from the origin, we need to cover 600 units in the x direction and 3 units in the y direction. So the coordinate for this point is 600, 3. Similarly, the coordinate for this point is minus 600, 3. Well, we only need one point because only one point can give us the value of a. We can say that this point 600, 3 actually lies on the parabola. So let's plug the values. Let's put x equals to 600 and y equals to 3. We'll get the value of a. So 600 squared equals to 4a 3. Let's cancel things out. 4 times 3 is 12. Divide by 6. We get 100 here. And then again divide by 2. We get 300. So 300 times 100, that's 30,000. So a is equal to 30,000. Which means the equation of our parabola is x square equals to 4 times 30,000 times y. Now we need to figure out this length. For that, we need another point. Which point should we pick? Let's pick this point. This point is 1 unit below this line, which means it's 2 units above the x-axis. So the y coordinate for this point is 2, and we are looking for the x coordinate. So this point is question mark comma 2. We need to figure out what that question mark is. So this is what we have to do. We need the x coordinate when y equals to 2 for this parabola. So let's figure this out. X square equals to 4 times 30,000 times 2. We're putting y equals to 2 here. So x square becomes, this is 4 times 3 is 12 times 2 is 24 times 10,000. Let's take the square root. X equals to root of 24, that's 2 root 6 times root of 10,000, that's going to be 100. And we take a plus and a minus sign because there's going to be two values, one here and the other here. There's going to be another point here whose deflection is 1 unit. That's also going to be same distance away from the center. So the answer is going to remain the same. X is this. So the distance from the center is 2 times 100 is 200. That's 200 root 6 centimeters. We can convert this back to meters. That's 2 root 6 meters or approximately 4.9 meters from the center.